All right, warm-ups for, what's today? Tuesday, 10/27. So if you're watching at home, take a good look or press pause and see if you can work them, and then come back and we'll go over them. All right, number one, find absolute extrema. So absolute extrema, think about the flow chart or table of decision making that we've made a couple times. Where are we headed, or what are we going to have to do for absolute extrema? A table. So table of values is what's coming up, although first I need to do critical points because that tells me possible extrema, and then for this one we'll do the table to get the absolute extrema. So that's just one branch of that kind of decision flow chart that we've made a couple times. So critical points would be first derivative is 0 or undefined. So 2x plus 4 is our first derivative. That's defined everywhere, so I don't have to worry about that part of it. But it's 0 when x is -2. So we've got our possible extrema at x equals -2. A table with the endpoints will help us figure out who's the tallest and who's the lowest. So -3 and 0 are the endpoints. -2 is on the interval, so I need to check it. That would be an interesting twist. If one of the critical points wasn't on the interval, then we wouldn't even need to worry about it, because we're only concerned with numbers between -3 and 0. So I'll plug these into f of x, into the original, because I just want to know their y value. Who's the highest, who's the lowest? So 9 minus 12 plus 2. If I plug in -3, so that would be -1. I plug in -2, 4 minus 8 plus 2. That would be -2. And if I plug in 0, well, that's an easy one. I get 2. So I have an absolute max. The tallest one would be at 0, 2. And the minimum, absolute minimum, the lowest one would be at -2, -2. Not always, but frequently teachers and makers of tests like to pick or like to rig the problem so that one of the maxes, one of the extrema is an endpoint and one of them is a critical point. That way we sort of test if you remembered to check the endpoints and if you got the critical points correct. So not always the case, but probably feel good if one's a critical point and one's an endpoint, because that when we rig the problem like that, it means we've tested everything we need to test about that problem. Number 2, use the table to locate the relative extrema of g of x. G of x is continuous. So g prime, if g prime is positive, what does that tell me about g? I'm going to add a line to my equation here. What's that? Slope is positive, and so that's true. Slope is positive. It means it's increasing is what I was going for. But slope is positive is the same thing, and you could even just do a little sketch there. That would help as well. At x equals 1, there's the derivative is 0, so that's probably a horizontal tangent line, which means it evens out, but just for that one brief point. If g prime is negative, then g is decreasing. Undefined, that's we don't know what's going on there. It says it's continuous, so it's not an asymptote or a jump. So that probably means it's a cusp, but we really don't know. And then if g prime is positive, g is increasing. So roughly increasing, decreasing, maybe a cusp, so maybe it's more of a sharper piece right there. But either way, there's a relative max at x equals 1, and a relative min at x equals 3. It didn't say, I should have added justify. I'll add that for fifth period. If it had said justify, you would say because g prime changes, let's see, the max is when it changes from positive to negative, and the min is where g prime changes negative to positive. It didn't say justify, but justify would mean you'd have to add this last part on there. So note to self, I'll add that for future warm-ups.